that's what this will tell us. A is bigger than B, or B is bigger than A, or A equals B so far. So here, things are coming from the right. So for all of the bits to the right, we say A is bigger than B or whatever. Right? It's a binary number. So we'll pass that information up. What we're going to produce based on the next bit is the same information. Okay? So all our logic needs to do is take a look at these bits and decide, and possibly look at those, and then pass the answer up. Now, once we have information like this, we have to pick a representation, because these are zeros and ones, and this is some meaning. There's no natural mapping from a meaning to zeros and ones. We have to make something up. That's a representation. On Monday and a little bit of Tuesday, we talked about integer representations, floating point representations. Right? So all we're doing is we're saying, well, for each of these answers, we'll pick a bit pattern. So let me pick a bit pattern. By the way, this notation, when we write the equations for the logic, inside our one bit slice, this will be C1 and C0 coming in. Z1 and Z0 are the outputs. This will just be A, this will just be B. When we put bit slices together, this is bit slice number n, and so we can name the information flowing between them. Okay? So, in order to build an 8-bit comparator, we'll take 8 of these bit slices and just link them together in a chain, just like we did the adder. So we've got 4 possible patterns. We've got 3 things we might want to mean. And so all we need to do is make up a representation. Now, I want to be a little careful because the reality is, the way we decide to map this meaning into bits is going to define what logic we end up implementing. So in many real cases, you might actually want to try different representations, because some representations will give you a small circuit and others will give you a giant circuit. Okay. And it's not always that easy to tell by just saying, oh, let me look at it. If you have more than a few patterns, sometimes it's a little easier. Here, what we will do is just sort of take a guess and say, well, let's say if they're equal, we'll pick something with equal bits. And if A is bigger than B, we'll make the high bit set, and a low bit not set. And if B is bigger than A, do it the other way, and we'll just leave this one not used. In practice, I did, while I was designing the example in these notes, I did look at a bunch of the representations. Right? I don't remember, but I think it says in the notes, I may have tried to do all of the representations kind of in my head, scribbling quickly on paper.